Hello! We're here, we're live, we got a special guest with us today for this exciting episode. I don't know if you can guess who it is. Have a relative idea of who it could be. We're joined by none other than Albert Einstein.
That's me.
I'd like to know how you got out of your grave after
I look
this
good
many
too,
years.
don't I?
You look pretty good, yeah.
I mean, it's been 70 years.
Your skin has held up really nice. It must be just like they do those like soil earthy facials.
Yeah.
Like a mud face. It's not gonna stay.
It's not gonna stay, but I would like for it at least to stay
until like somebody comes on and joins us and like watches.
Yeah.
Yeah, I'm surprised my mom isn't on yet, and she's late for a very important.
It's only sticking right here.
Date with Cosmos.
It's only sticking right there.
Yeah, we're gonna have to get some actual glue for. We might have to trim it a little bit for your Halloween.
Yeah. I can't even. I don't even think I can drink anything.
You can drink stuff. That's why you got the straw. Oh no. Oh. It got a little. It's quality. It's the quality makeup effects right there.
Nobody saw.
Nobody saw.
No, by the time I take my first drink,
safe.
it's gonna have to
Oh,
come
Jack's here. Jack, did you see his mustache fall off? How long have you been with us?
Oh, he saw
what
his
have you
mustache
seen
fall
so
off.
far? This is great.
Things I do for my fans, but it doesn't show up that we got anybody over there.
Oh, now it does.
Oh, I'm looking in the wrong place.
Oh.
Oh, I see the one.
Okay. Anyway. Hello. You're leading this show today, though.
I know.
By the way.
I'm waiting for it to fall.
You're waiting for it to fall?
It's about ready to fall.
I can
It's
see
about
it.
ready to
Oh,
fall.
there it goes. Oh, it was you the whole time?
It's me! Alright, well, I guess we aren't going to,
You need some of the quality Rolling Bluffs Planetarium beard balm.
Yeah. Well, I look really weird without the mustache, so...
Well, even Einstein, I'm sure, had to shave at some point.
There's Brandon.
Hey! Why did you even get Wi-Fi on the plane? Are you still on the plane? I thought you landed already. Anyway. You're just going to hold it up with your bottom lip? A stiff bottom lip is what you need to have during this episode. A stiff bottom lip.
Yeah, so you gotta lead the show now. Because I'm just gonna be like this.
Well, yeah, just nod along. This is...
Alright,
This is great.
This is not gonna work.
Great.
Too bad Brandon's missing all this.
I know. It's good times.
Alright, we ready?
Yeah, we're ready. We're ready to go. Let's
Yeah.
get the episode rolling.
I mean, we only have Jack and Brandon.
That's
so.
fine. I sent my mom the link, but she's got a life to live. Are you gonna try? We should get you like a stick, like on the old school, like a mask party.
Oh yeah,
or whatever.
yeah.
Get like a stick to it, and you can just hold it up, and that way you
Yeah.
can just take it off when you want.
Hi everyone, welcome to Cosmos with Cosmos. As always, I'm Einstein.
And I'm Liz.
Really, Mike. See?
Whoa!
I know, right?
For those of you listening, Mike is wearing an Einstein wig and a mustache that won't stick on.
That won't stay on. But we got to figure it out. So because this is Halloween right here.
Yeah. Vampire Einstein, and I will be Vampire Marie Curie.
Yes.
So far is the plan.
So welcome to our final episode of the season.
Yeah!
Yay!
Season 3 coming to a close.
Today, and if you haven't figured it out by looking at us on YouTube, me dressed as Einstein, we're talking relativity today. And what's the name of the show?
It's all relativity speaking.
Yes. So, all right. So, it might get us through at least to this first part.
No.
So, no, you don't think so? All right. So before we dive into all things relative, what are you drinking?
Ah, yes, I am drinking E=MC alcohol.
I forgot the name of that. Yep.
And it is basically peach sorbet with cherry vodka, white rum, and a splash of orange juice.
Nice.
What do you got?
I am drinking Einstein's Eclipse, which we'll talk about later. And it has cherry vodka in it with basically Dr. Pepper. So I'm going simple today.
Basically a cherry Dr. Pepper.
Yeah, it's basically
adult
an
cherry
adult
Dr.
cherry
Pepper.
Dr. Pepper. All right, before we jump into it, do we have what anybody else is drinking? Nope, we don't. All right, so follow us on all the things. Drinking Cosmos on Twitter and Cosmos with Cosmos on basically everything else.
Here, we'll just...
Yeah, that's not going to last there either. All right. So follow us on all the things. Rate us on iTunes and wherever you podcast. And tell all your friends. Let them know all about it. And also, don't forget to join us on The Hangover. Right?
Yeah.
Yeah. So
Hangover with us.
Which we don't know what we're going to talk about, but it's...
All right, so Jack has a hibiscus tea with mint ice cubes. Oh,
nice.
Did you freeze mint? How'd you make that? Tell us your secrets. And then my mom is drinking her usual, which I'm guessing is Earl Grey tea, hot.
It's
too hot. It's too hot.
Right.
I can't drink tea now during the season when it's too hot.
Yeah, but we're gonna talk about our sponsors here. We got some sponsors. We got 3 sponsors. We have Wildixia at Etsy. Katie's stuff. So please go check her stuff out. Great art, shirt art.
Links below. If you're watching on YouTube. Oh, actually no. If you're listening, in the links below.
Yeah.
In the description.
And we need a little bit higher. There we go.
It's
not straight, but.
Make it it's like a Bill Nye bow tie.
Oh, that's true. And also. Mr. Proctor Show. So go check out Ron's stuff. And if you are in the Omaha, Nebraska Council Bluff area, then check out Jack and his Rolling Bluffs Planetarium.
Hey.
Yeah, he's got all kinds of shows from the constellations of the world to all kinds of shows about dark matter and everything else.
And he can recommend a good beard balm.
Yes, definitely true. How do people have mustaches? I just don't know. But all right. How do you have a mustache?
I pluck mine.
All right. I even shaved to make this work, but it's not working. Anyway, join us also every other Wednesday where we drop the shot. You can check out our shot episodes. We take some bite-sized.
Shots of science.
Shots of science.
Shots of science. Little shots of science.
A little bit. It really is about astronomy, but
little shots of astronomy.
Yeah. So that's every other Wednesday. The next one is next Wednesday, right? So,
and I can't remember which one it is that's coming out.
We'll find out. So, as always, we have rules. If the puppies bark, take a drink. Good news is Amazon's already came. If there's a Star Wars reference, take a drink. Lord of the Rings reference, take a drink. And also, when the mustache falls off, we're just going to, when the mustache bow tie falls off, then take a drink.
I think it's pretty good.
It's probably going to stay. It also is getting that shirt fibers on it, and it won't stick to...
Yeah, we'll get some professional face glue for Halloween.
All right, we ready? Ready to jump into this?
Let's get relative.
All right. Also, if in the middle of the show I pull the wig off because I just can't take it anymore, you can take a drink.
How long will he last? Take your bets, folks.
I did the mohawk, the whole thing, didn't I?
I don't remember.
Show plus
but
hangover.
Maybe.
That was a year ago. All right, so we're gonna set the stage.
Yeah.
Sure, we're gonna talk about Einstein.
All right.
But we need to go back in time.
Ooh.
Yeah, I know, right? So Einstein. Relativity had been known about for hundreds of years at that point. Not
before Einstein?
Not Einstein's relativity, but the term relativity.
Oh.
Galileo was the first one to come up with relativity, and basically all relativity is
relative.
Yeah, exactly. I mean, at the heart of it, that's what it is.
How many times will I make the same joke? Place your bets, people.
Now, I was going to put that as a drinking rule.
No.
But I figured we'd run out of alcohol, we'd run out of drinks in the first 10 minutes.
Yeah, pretty much.
So, but basically, relativity is nothing more than having one person kind of see through the eyes of another person, to get the point of view of another person. And So if you have one person and, they're moving, and you have another person that's moving, it's a way for the two to be able to agree on time and velocity and things like that. The energy of a system. And so Galileo was the first one to really talk about it. And in classical physics, it's called a Galilean transformation. So
Galilean transformation.
Yes.
Oh, I should name my drink that.
And so it's basically, it's just a way in which you can say, all right, this person is going at a certain speed. Where are they going to be relative to me in like an hour? Or that type of thing.
Okay.
So, all right, so he's the first one to come up with it. And then, of course, the next person that we kind of want to talk about is Newton.
Good old Newts.
Yeah. Oh, how did the guy say his name? It was a very...
Oh, Isaac
Newton. And so you've heard us talk about Newton. We've
never mentioned any of these people ever before.
Newton's got 3...
He's known for his apples.
Yeah, he's got 3 obscure little laws of motion. He did some stuff with light. He also did something with gravity. This mysterious force at a distance kind of thing. But one thing that Newton came up with was that you have space. So
you have space.
X, Y, Z coordinates, but you also have time. They are separate from each other.
But equal.
And time, what? What would you say?
Is it but equal?
Yeah. But time, it moves at a steady state ever onward. And so time is always progressing at the same speed. 1 second is always 1 second. And it just does that forever.
And ever.
And ever and ever.
And ever. Until there's no more time. Could there ever be no more time?
Well, could be, yeah.
Okay.
At least as time as we know it. But and that held sway for hundreds of years until Einstein came and changed things around a little bit.
Einstein wants to shake the pot up a little bit.
He does. And we're going to fast forward to the mid-1800s, and a guy named Maxwell. He's from England, I think, or Scotland, somewhere over there in Great Britain. Maxwell, he basically... there's these 4 equations called Maxwell's equations, and they describe basically electricity and magnetism, and how these fields interact, and how currents are created by these fields and things like that. But one of the things that comes out of Maxwell's equations is that light is a wave. Yes, and also the speed at which light travels, 186,000 miles per second.
Oh, so he came up with the speed. He figured out the speed.
They figured out it. It comes out very elegantly out of the equations, and you're able to get the speed of that wave. Okay.
Is this before they figured out that light is a wave and a proton?
This is before. This is before. So Newton said that it was little corpuscles.
Corpuscles? That sounds like something you get with smallpox or something. Like I got some corpuscles. I gotta.
Yeah, they're little.
Need a cream for.
They're particles, basically, is what he's saying in 1600 speak.
Oh, that's nice, Jack. Can we just, we'll just take a little edit.
Oh!
Hey, it fell off. Take a drink, everybody. Oh, I'll leave my button. Jack has shared his mint recipe.
Okay.
And it's like, and the bottom of the cube is slightly green and the top is clear. That's kind of cool.
Oh, see, I like stuff like that.
Yeah, that's neat.
All right, so now, when you think of waves, Ocean, exactly. And so you have these beautiful waves that crash upon the shore, and the medium for those waves is water. So the water is undulating and creating those waves. There's also sound waves, and so if you're nowhere near an ocean, you experience waves all the time because if somebody's talking to you, these sound waves wash upon your ear and allow you to, or at least for some of us, to
for
actually
those
hear.
who aren't hearing impaired.
Yeah, and so it was always these waves had to be in a medium. And they thought that...
And the medium is like air in the case of sound waves.
For sound waves, or water for the ocean wave. And so they thought that the light traveling from the sun to the earth had to be going through a medium.
A medium of space, but space is a vacuum. There's no medium there.
Right, and so they called it the ether.
The ether.
Yeah.
That's also what, like, you sniff ether? Is that like a, I don't know, it sounds like a...
It does. But they thought it was going through the ether, and the
That's
ether
where
was
ghosts
the medium.
live. That's where ghosts live.
Yeah, up in the ether.
That's where you live now, Einstein.
I know, right? Except I'm here. I'm here today.
Thanks for joining us out of the ether.
Huh?
Thanks for joining us out of the ether.
Hey, you know what? My pleasure.
Yeah.
I'm sorry I lost my mustache.
And gained an American accent. But
you
well
know,
done.
it happens. I was in the U.S. for, 20, 30 years.
Yeah.
And so,
Yeah, you could
kind
get
of
it.
get it. And I'm buried here in the U.S., so...
Are you really?
Yeah.
Where are you buried?
New York, I think.
Oh, shit. We gotta go see
New
Einstein's
Jersey.
grave.
Or New Jersey.
That'd be really cool. My mom asked, do these waves really undulate, or do we just call them waves? Oh. Pause for plane pause. Why is the Air Force flying on a Sunday? Give me a break.
Right?
I don't know if you can hear the Air Force, but anyway.
Jesus doesn't want no flying. I'm assuming your mom's talking about...
like sound waves, like the waves, like light waves. Do they really do this motion?
Okay, so with light waves, really what's going on is the electromagnetic field is oscillating. So it really, at the end of the day, doesn't need a medium, and we'll get into that.
Okay.
So what's really going on is that the electromagnetic field is oscillating. And so it's not, it doesn't need, its medium is itself, which is really kind of hard to think about.
Okay.
But as the electric field of it expands out, the magnetic field contracts, and so they do this thing where they oscillate back and forth.
So it's not like a typical like wave, like you said.
Yeah, but if you were to but you can kind of think of this undulation as kind of like watching waves on the ocean. It's kind of like that. Sound waves are different. These are compression waves, and so basically, as the sound wave comes through, the molecules of the air compress, and then they, with each wave.
I think our mom is our Cosmos was Cosmos community greeter. She's learned, although it's Federico, so no R in there, first R in there, Mom. But I like that you welcomed Federico in, and Federico knew who you were, Einstein.
I know.
He had a mustache; it fell off. I don't know if you saw it earlier. I don't know if you were with us during that.
Yeah,
that part.
I really wish the mustache was staying. It really completes the ensemble.
It's also hot, so
yeah.
We got it.
All right, so at this time, they're still living in that Galilean way of thinking, in that basically that if you are in a plane, like Brandon right now, traveling at 600 miles an hour. Let's say Brandon on this plane is traveling 2,000 miles per second.
Oh, Brandon, hang on, buddy. You're gonna get here real fast.
You're gonna overshoot, real. Okay, so he is moving away from us.
He's redshifting.
Yeah, so he's moving away from us, and he turns on a flashlight in the plane. And so that flashlight, the light goes out at a speed of 186,000 miles per second relative to him.
Yeah.
However, he's moving relative to us at 2,000 miles per hour away from us. And so, according to Galileo, that light should now be 188,000 miles per second for us. Because we have to factor in the speed motion
of the plane with it.
Yes.
I knew my brain was going to explode a little bit.
Oh, you're doing great. No, you figured it out.
Okay.
You're doing great. However, so what they were thinking was, hey, we can measure this shit. We're on something that's going pretty quick.
The Earth?
The Earth.
Yeah, it's speeding around
the sun. And so what we should be able to do is we should create this experiment where we shine a flashlight and it goes through this like partially this partial mirror, and so it ends up the beam gets split as well.
Oh, okay.
And so part of it goes straight, hits another mirror, bounces back, and then these two beams actually come back together on this detector.
Okay, it's kind of like using like radar, where you're shooting and bouncing.
Yeah,
stuff
except
back,
you're splitting the beam, and so really what you want them to do is to come out of phase. You want the laser to come out of phase, and it's what LIGO does to detect
gravitational waves.
Gravitational waves.
Wait, what does come out of phase mean?
So, the light before it is split. All right, so it gets split if it's in phase. The crests happen at the same time, and the troughs happen at the same time. And if they go out of, and so if you hit the detector, it should just be a constant bright light.
Okay.
Because they are in phase. The crest meet with the crest. On the crest of one meet with the crest of the other, and it's in phase, and so it's a bright light. Whereas if they're out of phase, perfectly out of phase, then the crest of one will meet the trough of the other, and they'll cancel each other out.
Oh, okay.
And it'll be the dark. You won't see any light. And so what these two guys, Michelson and Morley, they conduct this experiment, and they thought that if we shine this light,
is it called the M&M experiment?
For you, yes. It's the M&M.
Thank you.
And so what they did was they aimed it in the direction of the Earth's orbit going around the sun. They also aimed it perpendicular to that. No matter where they aimed it, it was on this little thing that could rotate. And I believe it was on a thing of mercury that could rotate. So
careful.
We know how they died. So no matter which way, there was no change in the speed of light, and therefore Galileo's transformation, at least for the speed of light, is wrong.
Ooh.
Yes.
Well, I mean, as they say, it's all relative.
All right. So now,
my mom asked, "Is that the same as when they say it refracts?" I guess out of phase.
Well, refract is when the light gets bent. So this is...
Okay, so, and then she follows it up, looks like it bends. But it's not looking like it bends.
No, this is more reflections. Because you're using a mirror to reflect part of the light down. Actually, what they did was they reflected it up, so it has the exact same length of path as the other beam. And so it actually gets reflected, and then hits another mirror and gets reflected back down.
Okay.
And so it's more of a reflection than refraction. Refraction is bending the light, and so it was where you get colors that come out of it.
Okay.
And that's all based on wavelengths.
Yes.
Of the light. So Michelson and Morley proved that the speed of light is always 186,000.
It's constant.
Yeah, it is constant.
Constant. No change in it. I mean, it can go slower, or light can go slower based on
the medium that it's in.
Medium that it's in.
The medium that it's in, yes. And
it
so
can't
light,
go faster.
No, the speed of light in a vacuum is 186,000 miles per hour. Per second. And any other medium is going to be slower. You still cannot pass that speed, no matter what medium it's in. So
Can't do it yet.
Or ever. So, Mr. Einstein.
Yes, guten Tag.
Guten Tag. When I was 16 years old.
Ich liebe dich.
I love you too. I would butcher
I've exhausted my German now. I've exhausted my German. Shout out to Sasha Kriegel at where's Sasha at? I can never remember. Hamburg for teaching us how to say I love you in German.
Yes. All right. So, and this is just a great story. Um, I mean, it's not really going to go too much anywhere, but
This is a great story that doesn't go anywhere.
but it just. What were you doing when you were 16?
My mom's watching. I don't want to say.
Okay.
No, what was I doing? I don't know. I was hanging out with friends, watching, sitting on the couch, watching a TV, likely, a lot of anime. Driving friends to their concerts that they played in.
When Einstein was 16.
Oh, no, what? Oh, okay.
Einstein, when he was 16, he had his first real consequential thought experiment. Einstein loved the concept of thought experiments where you just think about things.
This is what he did all day when he was 16.
Yeah, and so what he thought about was, hey, what if I could go at the speed of light and catch up to a light beam? And he was like, what would I see? And I mean, basically, it would be that whole, he would see the wave action. But that led him to think about this thing, this deeper, and it led to his early years in physics as a patent clerk.
Oh, yes, I remember this.
Yeah,
okay, yes.
Coming up with the special theory of relativity, which he actually built on two ideas. Now, he did this in between examining, patent applications that people put in Switzerland. And he came up with, and he was ridiculed for it, but he came up with 3 just incredible papers in 1905.
How old is he at this point?
1905, I think he was born in 79, so he was like 26-ish. Yeah, so what
would we have more Einsteins if we didn't have, Netflix? Anyway.
we would have more Einsteins if education were readily available for everybody.
Yeah.
So, do we want to get into politics?
No.
All right, so 3 papers without really comment on the first 2. A Brownian motion of molecules, how they move.
Okay.
And so the second paper, which he actually won the Nobel Prize for, describes the photoelectric effect. So how you get everybody who's got these little photo cells that making energy from the sun. You can thank Einstein.
Oh, solar
for
panels.
Figuring out
For solar panels.
Solar panels.
Thank you, Einstein.
Figure out. He said how it could work, and how the energy that the light needs to knock off those electrons.
So we could have been harnessing solar energy for a lot longer than we have been. Oh, we just needed the technology to catch up to his. So his was like, here's what I'm thinking about.
Yeah. And then of course also with special theory of relativity.
Yes. Okay.
Which involves moving in a straight line and constant speed. So there's no acceleration whatsoever. So this is not real life situations.
So I'm not driving, is what that means in this experiment.
Yeah, or me, or anybody else. Yeah, he did think of all that without the electron microscope. That actually was in the 1950s, shortly after his death, I think.
Oh.
All right, so it's built on 2 ideas.
Okay.
The first idea is that the laws of physics apply to everybody the same way in the universe. And so the laws of physics for me here are the same as they are halfway across the universe.
Okay.
Or the same...
in a galaxy far, far away.
Exactly. Or the law... Okay, yes, that's true. I forgot. Star Wars. And so, or the same in Bend, Oregon, or...
Italy,
or with Brandon
Omaha,
on a plane.
Or Brandon.
Yeah,
and experiencing the same physics.
And so we're all able to, make calculations and predictions about what's happening for Brandon if he spills a drink that he probably had on the plane until he flies into Utah airspace and then becomes illegal, basically.
As soon as they reach Utah, they have to like lock the cabinets.
Yeah.
No more drinks, people.
It's Sunday. It's the day
Sunday
of
in
our Lord.
Mormontown.
But the second thing, and that's easy. That makes sense.
Okay, yeah.
And the second one, which actually is revolutionary, but we see it with Michelson and Morley, is the speed of light is constant for everybody.
Okay.
So that means if I shine a flashlight, I see the light at 186,000 miles per second. If Brandon shines that laser on the plane, I still measure that light at 186,000 miles per second.
Yeah.
And
if Zoobglorp, 10,000 light years away, shines their flashlight, same speed.
So this has amazing repercussions. These two simple things, especially the light part, just has amazing repercussions. The only way in which that you could have a light beam travel at and for Brandon on the plane, because he's going 600, he's going 400 miles an hour.
Yeah, where fast planes go.
Yeah, and so the only way in which that you could make that light speed constant is to slow down time. So time gets dilated. Time dilation is the thing. But so the light beam moves, with the plane, but it's still 186,000 miles per second. And so when you do the mathematics is, and we're definitely not going to get into that.
Yeah, there's a little bit more than 2 + 2 involved.
Yeah.
So out of my.
Yeah, there's things called Lorentz transformations and things like that, but you basically, the only way in which you could make the speed of light constant is if it goes a greater distance, and from our perspective, is that time has to slow down for Brandon to make the speed
That's why flights
constant.
just feel like they take forever when you're moving
a
lot
right?
faster. My mom asked, how come we can't feel how fast we're going once we get to that speed?
Because
like we can't feel that we're going 700 miles per hour on a plane?
Yeah, because with constant velocity, your body, is used to it, but velocity really is always relative to something else.
I mean, we don't feel like we're moving yet. We're moving real fast right now around the sun.
Yeah.
But I feel like
I don't really
I'm standing still, sitting still. See, I'm not moving, but at the same time, I'm moving real fast.
Yeah, and this is called relativity because the motions are always relative to something else.
Yes,
there's the implicit thing for physics anyway is that out of those, at least really out of the first one, there are no preferred reference coordinate systems, reference systems. So so from Brandon's point of view, he's not moving 400 miles an hour. He's actually he's heading towards us now, but he's coming towards us at 400-ish miles an hour. From his perspective, from his point of view, we're actually approaching him at 400 miles an hour as he sits still 3,500 feet above the ground, 35,000 feet above the ground.
Interesting.
Yeah, and so
crazy.
And that's the crazy thing about relativity is that okay, so I'm not saying this is going to work because it won't work, but yeah, so you're driving down the road.
Okay.
75 miles an hour in a 35 mile an hour zone.
Okay, that's accurate. Yeah.
A cop shoots you with a radar gun.
Okay.
We're white. He gets us with a radar gun, and it says that we are going 75 miles an hour.
Uh-oh.
Yeah. I mean, you could say,
that's a felony.
Dude, I'm sitting still. You're the one that's coming at me at 75 miles an hour. You should give yourself a damn ticket.
I'd like to see that hold up in court.
It won't. It won't.
Just break out just all this math, and then they'd be like, we don't want to deal with this. Let him off. Let him go.
Yeah. But the cop would probably say, but you're moving 75 miles an hour relative to my position or relative to this position. So
That's why the trick is get behind like a big truck or something, or next to
Yeah.
a big truck, because that radar gun's going to measure the largest object moving.
unless
Unless it's laser
unless it's
sighted.
laser.
Unless it's laser sighted or whatever.
Yeah, if it's laser, you're
Then
in
you're
trouble.
screwed.
But anyway, yeah. So the implications are time slows down, but also because you got to put these, you got to put that time, what you measure for time, into these transformation equations. Links actually contract as well, and so from our point of view, if Brandon is on a plane that's going close to the speed of light. We see that plane actually contracts. It gets smaller. So not only does time...
We got like a Willy Wonka situation happening where
but
he's
only in the direction of the motion. So it's so not only do we see for Brandon that time slows down, but he also gets skinnier, which he doesn't need.
That.
He doesn't need that. But the plane actually contracts, so it's not as long from our perspective. It also seems to rotate a little bit. And so we're able to see kind of around it a little bit as well. But also, Brandon.
Nice.
But Brandon is also heavier, which is what he needs. He needs a little bit more mass. And so the faster you go, the more mass you pick up. You get more massive.
But why? Because you're still made of the same amount of stuff. So why do you get heavier then? Oh, I've stumped Phancy Physics Man.
Well, it all comes down to conservation of energy. And so it's in conservation of energy. So basically, kinetic energy is related to your mass, and it's also kinetic energy is equal to 1/2 in Newtonian physics. 1/2 your mass divided by 2 times the velocity. I don't think it's squared, but it might be squared. MV squared. Yes, it's MV squared. Momentum is MV. So, so if you are changing, velocity is related to distance and time, so if you're changing that, your mass is also going to change. And so your mass increases. And it is actually what prevents you from going past the speed of light. Your mass increasing is what prevents you from going faster than the speed of light. Because if you look at the special theory of relativity, as you approach the speed of light, your mass increases exponentially, and you're just always too massive to go beyond.
You get too massive to go the speed of light. I don't know. I think my brain can't. It's been too much for my brain now. Hey!
Ron's in the
Welcome,
house.
Ron!
All right. But also what comes out of the equations with this conservation of energy is E equals mc squared.
E equals MC alcohol.
Yes, indeed. And so what Einstein said was you can't just have that kinetic velocity. You can't have that kinetic energy. There also has to be this rest mass energy. And so
rest mass energy.
Yeah, which is the MC squared part.
Okay.
Which is the part that makes atomic bombs go boom. That makes stars shine. That all of that. And so E equals MC squared is uniquely Einstein. Because some of this stuff, like time dilation and length contraction, this was all kind of figured out prior to Einstein. But Einstein put it all together and actually said what was going on. Made a nice
little package out of it,
He
a little
did.
bow on top.
He did. And out of the equations came E equals MC squared, which is the most famous equation.
Ever, I would think.
I would say probably ever.
I mean, I remember...
One of them.
I can remember y equals mx plus b, the equation for slope, and d equals mc squared. And those are quite those ones. Jack says all protons of the airplane have complementary cookies, so they're more massive. And then my mom says, can't pop my protons.
All right. But remember, this only applies to things that are moving in straight lines at constant velocities.
Okay. So no acceleration, no turning,
No acceleration.
no zigging, no crazy maneuvers.
Yeah, and this is not the way the universe.
No, the universe is a crazy, wild place. It's extremely strange.
What do you
Crazy
what
and
is
cockeyed.
keeping you in the seat right now?
Gravity?
Yeah.
Okay.
So exactly, and so the universe is permeated with accelerations, and so you don't have. I mean, sure, you can use special relativity.
If I stand up, I'm accelerating myself.
You're accelerating
out of the
yourself
seat.
up.
Yeah.
Yes. I mean, you can make, with special relativity, you can make specialized calculations, but if you do want to actually really look at the whole universe as the universe as a whole, or your existence, or all that kind of stuff as a whole, you need to actually also include gravity acceleration. And so Einstein was largely ignored with special theory of relativity. In some cases, he was ridiculed.
It's because of his hair.
Because of his hair. And the fact that he married his fucking cousin.
Oh.
Yeah, and so, yeah.
And so did Rudy Giuliani. But one of them more important than the other. Einstein.
I didn't know that. All right. Anyway, so he's not satisfied with special theory of relativity. He wants to include
more?
Yeah, he wants to include accelerations.
Okay.
And the journey to include accelerations was like an 11-year journey.
So it's like the Lord of the Rings, the Fellowship, going on their journey that took
a long time.
A lot longer than 3-hour movies.
All right. And so it all begins for Einstein when he's sitting in his patent office and he's watching a window cleaner.
I've watched window cleaners when I was in the office.
All right, well.
And I've watched them, and they're actually, it's kind of just mesmerizing just to kind of watch them, and I'm like, that looks kind of fun, just hanging there on the side of the building.
Let's see if you take it where Einstein took it.
Okay, I'm not going to take it where Einstein took it.
Okay, so.
This noggin?
So he's watching the window cleaner, and what he thinks about is, what if the guy falls off?
Yes.
Falls off the ladder.
Right.
And so he immediately makes him fall off. But what he does is, okay, not in real life.
Fall off.
I like, fall off! Now! I got physics to do! No, but he put himself in this guy's falling. Alright, so he makes the guy fall off the ladder, and he puts himself in that position, and he thinks about, what am I experiencing as I fall to my death? Normally, normal people think about, oh shit, this guy's gonna hit the ground, he's gonna die.
But if
Einstein,
you're the guy falling, though, you're just like, fuck.
Yeah. But for Einstein, what he did was he put himself in the guy's shoes. Very empathetic of Einstein, I guess. But he also removed the Earth, so nobody's going to die in this.
Oh, that's nice. Just take away the ground.
Yeah. So, and so the guy is falling, and what Einstein realized was that he is basically in free fall as he falls down. And the deceleration is due to the Earth, right? And
right. That's going to decelerate you pretty quick.
Yeah, and so watching himself fall in this thought experiment, he realized that gravity and acceleration are the same thing. Now, for us in the 21st century,
right? We have other forces that help us.
Well, but we kind of take that for granted. We understand what that means, but in in 1906, whatever it was, we weren't sure that accelerations were actually different from gravitational accelerations.
Okay.
And so. So that was his first idea, that gravity and acceleration are the same thing. So here's a thought experiment for you. All right, you are in a house with no windows.
Okay.
So you're enclosed in this house, and
Right.
you have the bathroom scales on the floor, and you get on it,
Okay.
and it says whatever your weight is.
All right.
Okay. So you know that you're in a house.
Mm-hmm.
Gravity's pulling you down. It's causing that. What if your house is in a rocket, you're in space, and you are accelerating up?
Mm-hmm.
You have no windows. You do not know that if you were in a rocket or if you are actually on the Earth and the Earth's mass is pulling you down. So is it due to the Earth pulling you down, or is it due to the rocket accelerating up, or an elevator going up, or whatever? And so that's what it led to. That gravity and acceleration really are the same thing, and it is called the principle of equivalence in Einsteinian speak.
Okay.
So Einstein in his thought experiment said that gravity and accelerations are the same thing. And I mean, guy lived in his head.
Well, clearly, all he did was think about weird. I'm that window cleaner falling. Jack said, Ron said, the world's most murdery thought experiment, which, yeah. Jack says, with this level of morbid conversation, Schrodinger might actually have come back to life in his casket. Well, you never know until you open it.
That's true.
And Brandon has landed.
That is really good. That's worth a break.
He's happy that that Earth's mass didn't bring him down faster than anticipated.
Oh, I know, right? All right. Well, I'm glad you're on the ground safely. Okay, so let's go back. And from this, Einstein was able to kind of figure out that really and truly what's going on, because he removed the Earth in this thought experiment. And from this, he was able to figure out that gravity really is the curvature of space-time, and not you meeting the ground of the Earth and the Earth pushing on you. And so gravity actually originates from the curvature of space-time, and that's why you see like these like a bowling ball and on a trampoline.
Oh yeah, and then all the marbles go towards it and stuff.
Yeah, and so he was able to come up with how this curvature of space-time actually makes time slow down as well. So if you have flat space, so there's no mass, and points A and B. Light goes from A to B at 186,000 miles per second. Straight line, boom, whatever.
Cool.
But if you add mass, it deforms space-time, and so it makes this gravitational well. That distance from A to B is actually longer. Yeah. And the only way in which, remember,
it's like taking a detour a little bit.
Well, I mean, it's going the straightest possible path it can go from point A to point B. It's just that it is a curve. It's not a straight line. Like in flat space, it is a curve. And that curve is longer. And the only way, remember, light has to go 186,000 miles per second. And so time has to slow down when you're near a more massive object to make the speed of light constant. 186,000 miles per second. Your brain's still there.
Is it? I can't. We won't know unless we open my head.
That's true. So, general theory of relativity comes out. It took. He actually needed
I like
help.
how you have the like, oh, this is just general relativity. Like we've already had the special one. This is just general. Relativity. Maybe they should have named it like extraordinary relativity.
Yeah, well, yes. I don't know how to answer that.
I don't know.
The special comes about that it is a special case. And so Einstein in 1905, he was even saying, this is a special case. It is the special case in which everything moves in straight lines and constant velocities.
Okay. All right.
In other words, you're not going to see this shit in real life. And so and so the general is where he actually brings in the accelerations, the gravity, and it's more generalized.
Yeah.
Look at the theory. And I forgot where I was going with this, but anyway, he comes out with he had help, Marcel Grossman. So Einstein knew that, holy shit, we're talking about geometry here. We're not talking about flat geometry, which what we are used to all the time when we do trigonometry, and
Yes, when I do trigonometry,
and when you calculate the circumference of a circle, this is all based on flat geometry. Euclidean geometry is what it's called. But when you have geometry of like curves, it's called Riemann geometry.
Riemann.
Yeah, yeah. And so Riemann. He had a friend. Einstein had a friend called his name was Marcel Grossman, and he had just come up with his PhD dissertation on the mathematics of like curved surfaces and stuff like that. And so Marcel Grossman helped Einstein come up with the mathematics of general theory of relativity.
Okay, so what did? They just sat in a room thinking together?
Well, Einstein...
they were each in their own heads, and then...
Einstein, he told Marcel what...
Yes, right. Who's my special theory of relativity?
Yeah. Einstein told Marcel what's going on, and Marcel...
Here's the deal, man.
Yeah.
Here's what I figured out with all my daydreaming.
But Marcel's the one who mathematically
did
formalized
the math
it.
For him.
Yeah, he formalized it.
There's always somebody who does the math, like Kebby Keps.
Yeah.
Doing the math for Tycho.
Yeah, and the thing is, all right. So the math is the language of physics.
Yeah.
And it at the end of the day is what you need to be able to make a prediction.
All right. So basically, you always need a mathematician.
So I can say all day long, Earth goes around the sun. Whatever, and you know what? There might be some evidence that proves that. But you also kind of need to have that Newtonian formulation of gravity, the laws of motion to actually be able to predict.
Oh, right. Say
to
like,
make
hey,
predictions. Yeah.
Here is when Venus. You can see it here at this such a time.
So math is not just a way of formalizing something; it allows you to make predictions.
Yes, like for Uranus being discovered via math rather than actual Neptune, whichever, whatever.
Nope, you got it.
One of the
you got it.
ones.
Neptune was not in its proper place.
It wasn't. Yeah, it wasn't in its proper place, and they're like, wait, but it should be here.
Yeah. So out of general theory of relativity comes, time dilation and all this kind of stuff. Basically, the closer you are to a massive object, time moves slower for you. So for people on ISS, International Space Station, time is moving a little bit faster
for them.
Yeah, and so.
But like by.
Oh, it doesn't even matter.
Fractions, like it's not a noticeable.
It is fractions.
They're not like
fractions of fractions.
Like a minute behind everybody.
Yeah.
Like it's.
Oh, I'm gonna die 4 years earlier.
It's imperceivable, basically, to us, unless you have an atomic clock. Check out our atomic clock episode.
Yes. So they actually measured time dilation with an atomic clock. In the 1970s, they launched one, and they were able to to show time does slow down the faster you go, and also time is moving at a different rate than the higher up you are above the surface, and you experience it every single day if you're using GPS. Those GPS telescopes, satellites is what they are. They have to use Einstein's general theory of relativity to make the calculations as to where you are. Otherwise, you would be off 6 or 7 miles every day. And so, so general theory of relativity is what is responsible for what's going on underneath GPS and allows you to get from point A to point B, and allows
Yeah.
GPS to know exactly where you are in a weird kind of way. There are some proofs with this, with general theory of relativity, and this
Proofs meaning math.
Observations.
Observations.
Yeah.
Okay.
So yeah, I'm sorry. Yeah. So there is some evidence.
Okay, thank you.
Evidence.
Okay. I just assumed you meant it in a math way because I was like, "Ooh, he's being fancy math terms with proofs."
Yeah. No, but that's really good though,
Oh.
actually. So one of the weird things about Mercury is that Mercury, when it orbits the sun, where its most distant point away from the sun, called aphelion.
Aphelion?
Aphelion? Yeah.
I say aphelion.
Yeah, it never
Aphelion.
comes back to the exact same place. It actually rotates forward a little bit with every single orbit.
Fucking
So
Mercury.
it's an open orbit. It's not a closed orbit. And so it's like the entire ellipse that Mercury is orbiting around the sun with. It actually rotates as Mercury goes around the sun.
Mercury.
Yeah. And so Newton was never able to close that gap. He was never able to, with his theory of gravity, explain why Mercury is doing
Why
this.
Mercury's weird.
Yeah.
He's just a little oddball, a little
Yeah.
rebel.
Einstein turns his attention to Mercury. And,
Uh-oh, Mercury, watch out!
yep. And out of his calculations, precisely describes Mercury's orbit.
Wow.
And, and I've said this before, and it came up in this video that I watched, but I've said it before, but there's a moment where you are the only
Oh, yeah, we
person
talked about this. Brandon loves this.
in the entire universe that knows
Knows.
exactly how the universe works.
Yeah.
At least with regards to
Well,
this.
I wouldn't say the entire universe.
Well, yes, but
But
okay.
as far as our own solar system goes, then yeah.
You are the only person on Earth,
Mm-hmm.
and most likely the only person in the history. I'm not saying that Einstein was the only one who thought of this,
But,
but
knows.
no, he was probably the only one who thought of it.
Yeah.
But anyway, you're the only one. Okay, so he knows. He releases this to the world, and it's met with, okay, this is kind of cool, whatever.
All
But
right.
where Einstein becomes a fucking rock star is he makes a prediction where if you see an eclipse, if you take a picture of an eclipse, all right, so where an eclipse is going to happen. 6 months before that, you take a picture of that same part of the sky, and you meticulously note where all the stars are. Come back to the eclipse. And what Einstein said was, as light comes through past these massive objects that are deforming space and time, their position in the sky is going to be altered. Light changes its direction.
'Cause it's bending.
It's bending. It gets bent. Gravitational lensing. It gets bent. And you're able to make a prediction about the sun and how much it will bend a star's light as the light goes around the sun or tries to go past the sun. And so what they did was there's
Dude.
Sir Arthur Eddington, kind of a big guy in astronomy world. He took a picture of the sky, meticulously noted where the stars are, and then at the time of the eclipse, which was on May 29th of 1919, he goes down, just hanging out the island of Prince Pia, whatever it is, which is off the west coast of Africa, and he takes a picture of the eclipse and a star. Actually, a few stars.
They're visible.
They're visible, yeah, because
It gets a little dark.
the sun's light is being blocked by the moon. You can see these stars, but they're not in the right place.
Yeah.
They're not in the.
Not where he initially measured them as.
He's not where they initially measured it. And it is precisely where Einstein said they would be. And Einstein becomes a fucking rock star.
Nice.
He becomes.
Oh God. Oh gosh.
Okay. All right, you gotta leave my hair alone. I mean, I'm dead, for God's sakes. Yeah, and he becomes a rock star. People just recognize him everywhere. He is a celebrity.
And I thought only Brian May was the only rock star astrophysicist out there.
Oh, well done. Well done. And so that's why I'm calling my drink Einstein's Eclipse. And it basically told the world that the general theory of relativity describes the universe.
It's legit.
Every single experiment with the special theory of relativity or the general theory of relativity has confirmed the theory of relativity. There's
been nothing that has been like, oh,
Einstein was wrong.
He's wrong. Everything.
And where we know Einstein is wrong, we know all about it, and it has to do with black holes. All of the general theory of relativity.
Fuck everything up.
Yeah, the general theory of relativity does break down at the center of black holes.
They're the real rebels of the universe.
I know, right?
They don't give a fuck. Black holes don't give a fuck.
It breaks down at the center of the black hole, the singularity. Singularities in physics just means that the result is infinity, which we know is not a correct result. And so we know where general theory of relativity breaks down, and it breaks down at that boundary between gravity and quantum mechanics.
Quantum.
And so quantum mechanics and general theory of relativity don't talk to each other because they are different types of theories based on different things. Yeah. And so they need to be combined, and that's for the future.
You got to really take a quantum leap to get there.
Well done.
This is what I'm here for, people. This is what I'm here for.
So black holes, direct, straight out of general theory of relativity. Schwarzschild got the first solution of a black hole during World War I on the Eastern Front.
In the trenches.
In the trenches.
Right? I mean, what else are you going to do in the trenches? You might well figure out some science.
Yeah, so he was able to figure it out, and then he died a few months later. But also gravitational waves predicted in 1916. Discovered in, actually it was in 2015, but announced to the world in 2016.
With LIGO.
Yeah, where these two black holes merged together and released 3 solar masses worth of energy in gravitational waves, which is E equals mc squared.
Hey.
That was, it comes out of that. One of the really cool things about that was the peak power output was 50 times the entire visible universe, which I did not know until I was doing a little bit of research. That melts my brain. That melts my brain. So, one final thing with regards to deforming space-time. It's not like matter just has to conform to whatever space-time throws its way. A very famous astronomer named John Wheeler, in this very short sentence, basically tells you all that you need to know about general theory of relativity.
Here's your cheat sheet, everybody.
Space-time tells matter how to move, and matter tells space-time how to curve. So they're very related to each other. And so if you look at the equations, there's this beautiful symmetry between how space-time curves and how the matter moves with it. But the matter and the energy, John Wheeler was leaving off energy, but the energy and the matter combined deform space-time. And it's from this simple 2 ideas of the speed of light is constant for everybody, and that the laws of physics are the same for everybody. That you're able to get the Big Bang. That you're able to make predictions about the Big Bang. That you are able to have GPS. That you can see stars not being in the right place, quote unquote.
And a good example of gravitational lensing is James Webb Space Telescope's deep field image.
Yes.
You can see in Hubble Deep Field, you can see some gravitational lensing, but James Webb's image, you can really see the gravitational lensing. Like, it's so obvious that there's just a bending there.
Yeah, and so I think in a hangover we'll get into this whole twin paradox thing. But
Twins, don't trust them. I'm just kidding.
I've seen enough of them in Glow Up. It's just England is just
what a
teeming,
what a reference.
teeming with twins. Scary. What was that movie where you had twins?
A Shining? The Shining with the twins in the hallway?
Yeah.
Mm-hmm.
Yeah.
And then the elevator filled with the blood waterfall that comes up. Yeah. Good stuff. Here's Johnny.
I mean, it's hard to get relativity down to 65 minutes.
I know.
But I tried.
You did. I would like to point out Ron's thing that he said as he tells his students, you are the most important person in your life. Even if you disagree with me, you are still the person who's deciding that.
Yeah.
I like that, Ron.
I like that. All right. And
my mom asked, how do black holes have some relation or speed of light? Or my mom's brain is melted as well.
So how do black holes have some
cover that in
relation to
Hangover.
light? I don't know what the question is.
Okay, you refine your question, Mom. Let your brain recover a little bit, because this is a little bit melty.
Yeah, relativity, and the thing is Einstein did all this as a patent clerk. He did it.
Basically, black holes, like light cannot go fast enough to escape the gravity of a black hole. I don't know if that answers your question, but
right. Yes.
But
the event horizon. Yeah, we can get into that.
Well, yeah.
But Einstein did all this while he was a patent clerk.
And just thinking, he's not. How bad of a job did he do as a patent clerk? Because he's just sitting there. He's supposed to be reviewing patents, and what's he doing? He's imagining window cleaners falling to their deaths and figuring out.
Well, okay.
Space-time and gravity and weird shit. He's just sitting there daydreaming all day about just what ifs.
But so he also went home and basically avoided his wife.
Well, it's his cousin. I mean.
No, the cousin was later. He was married twice. All right, we'll get into the hangover.
Anyway, yeah.
All right, thanks for joining us.
Wasn't very personable.
No, he wasn't.
Except for that one picture where he looks personable.
Sticks his tongue out. Yeah. Thanks for joining us.
Yeah.
And this is the final episode of season 3. Join us again, not in 2 weeks, but in 4 weeks, whatever date that is. I don't know what it is.
I don't know either.
But we're going to take a small little vacation from...
a little break,
And then we'll come back to it, to a topic to be discussed later.
But keep an eye out for episodes of The Shot every other Wednesday. Little shots of sciencey goodness down your tummy.
In the meantime, join us for the hangover, and we'll everybody have a great 4 weeks, and we'll see you. Stay safe, stay healthy. Okay, you gotta leave it alone. Cheers, everybody. Bye.
We'll see you. All right, for those of you with us here, stick around. We'll be back for the hangover in a little bit. Welcome back, everybody. We're back.
We're back.
I'm surprised you still have it on. I mean,
It's really not that bad.
it's not that bad?
It's not that bad. Until like you pulled on it and it got all into and
Are you gonna try growing your hair out now?
God.
No.
Well, the thing is though, is that like there's a little bit of baldness right here. There's a little thinness right here. But I have thought about, can I just take it long enough to grow my hair out and do a mohawk? But I don't think that it's ever
It's
going
gonna be a full. It'll get a little.
Yeah.
Yeah.
So the problem is I really do get to where I don't.
I know. Yeah, you don't. Like
It's just I can't do it. But it's not too bad right. Oh well, no, I can hang it down my
You like
face.
it hang down? Yeah, I like this one that was like over your nose. That was kind of fun.
Yeah, it's very like Kurt Cobain-ish.
Oh,
So.
I can't. You got more volume than I do. I gotta. I can't. I don't have enough volume.
Well, all right. So Ron, I do have
He
this.
does have the mustache on. You came in. The mustache would not.
It doesn't.
It doesn't stay. It doesn't stay on.
I need some industrial strength.
Like
glue.
SFX prosthetic glue.
To where I can't get it off.
Yeah.
Or if I
It's
do
gonna
have
be
it, I end up being like John Rhys Davies, where I'm allergic to it.
Oh God.
somehow.
Oh God. Yeah, but it's gonna be a vampire Einstein for Halloween, and I'm gonna be vampire Marie Curie.
Yeah, it's gonna
I need
be.
to get like a black Victorian dress.
Yeah, it's gonna be great. Oh shit! I need to think about what I'm actually gonna wear.
Yeah. I don't know.
I mean, the
Einstein wear?
stereotype. Well,
A
it
suit?
wasn't. The stereotype is the lab
Like
coat,
a
but it was
tweed suit?
never a lab coat. Yeah, I need
I'd
a
like
tweed.
a tweed suit.
Yeah, Brandon, you got a tweed suit?
Oh, well. Even if he does.
I got some weight to lose. You got a lot of weight to lose.
I mean,
Holy crap! I got a lot of weight. All right, anyway.
Anyway.
Welcome back!
Yeah, The Hangover! Einstein and Mike, yeah, wild physics guy, Phancy Physics Men. Phancy Physics Men.
Yeah, I don't know about that, but
Instead of the show Mad Men, it's Physics Men. And it's just, that could, ooh.
me and Einstein.
Yeah.
Oh, that would be great.
The budding adventures of...
I have to tell you that like my mom is who instilled, like Einstein is my favorite physicist. He basically just completely changed our view of the universe, but I was introduced to Einstein by my mom because Einstein is actually my mom's, or was my mom's favorite scientist as well. And so as a kid, she introduced me to this person that was Einstein. And she might not like it, I don't know, but I think that might have been what drove me to really fall in love with astronomy and to fall in love with physics. And Mom, it's your fault. That's all I can say.
She can blame the atheism on herself.
Yeah.
I like Ron's idea, Einstein and Oppenheimer, but there's a dark turn.
Yeah, true. So, a lot of people think that Einstein was, really kind of in the trenches and responsible for the atomic bomb. He really wasn't.
He fled in Germany.
Well, no.
He
no,
left.
All he did, his entire role in the Manhattan Project was that he went to FDR. He wrote a letter to FDR, and he had a meeting with FDR, and he was like, you have to do this because basically the Germans are doing this.
Oh, right. It was, yes, that's right. Right. That's what it was. It was like, hey.
The Nazis are doing it. I think you do need to clarify, but it's the Nazis. But Oppenheimer is the one who really was the head of it.
Oppenheimer always makes me think of like a symphony. Like it's a symphony.
Yeah, and Ron actually has it in the chat there. It was his quote, his famous quote after they detonated was, "I am become death, destroyer of worlds," which is like an Indian thing, like not like Native American, but like Indian. And it's Yeah, and what is insane is when right before they were to detonate the atomic bomb, they did not know what like the atmospheric reaction was going to be.
No,
and
I mean they didn't even know
they had
the physical
calculations. They were
consequences.
reasonably sure, but there's always uncertainty. But Einstein went to FDR, and he basically initiated the Manhattan Project. But he was a devout pacifist, and so it was a real kind of internal struggle to do I do this or do I, because the Nazis are Hitler's gonna be doing it. He's gonna be looking for a way to make this bomb.
Yeah.
Do we do this? And of course, they did it.
And ironically, not used on Germany.
Not used on Germany, but used on Japan twice. And you know, Japan does have as the only country that has that has been inflicted upon. We understand, and so Japan, among everybody, understands the horrors of this.
Yeah.
And for all you warhawks out there, I mean, it's easy when you can say, I want to send somebody else's son someplace, or I want to drop an atomic bomb on I don't know, Russia, whatever, China, pick a place. There's repercussions to this. There is death, destruction, maiming, misery that happens up underneath those bombs. And it doesn't have to be.
Those aren't real people, because I'm not personally involved.
Yeah, it's all somebody else's kid. But anyway, so
what did I say yesterday that I was like, well, what I said was stupid, but then you liked what I said when we were watching the new Bill Nye, The End Is Nigh. And I was like, we've gotten like, what I say, we've gotten too smart to that. Then at the same time, we're like too dumb to use. What we've done smartly or some shit.
Yeah, but it was a really good way of to say it.
Yeah.
You know, it's it's like
like we've developed, we've gotten we're so smart, but are too dumb to use what we've developed smartly.
Yeah.
Something along those lines.
Basically, we're smart enough to do a lot of damage. Basically, is what it is.
That's a much better way.
And you know, it's that's basically what it is. And Einstein, really and truly, physicists at the end of the day. Okay.
Physicists just want to physics. Physicists.
Physics gonna physics.
Physicists
are gonna physicist.
Physicists just want a physicist.
God, that's so hard to say. Physicists just want to physics, everybody. Anyway, all right, we're all human. We all physics on fizz. Physicists do have. They have religious views. They have political views.
Because they're people.
Because they're people. People gun people. And
people gun people.
But at the end of the day, physicists ultimately want to truly understand the nature of the universe.
Yeah, they're scientists.
Yeah, and Einstein.
Unless they work for Ken Ham.
Yeah, then they're not really. But Einstein, I really want to poof it up.
Yeah, but you want to poof it up more? You want to get some volumizing spray and throw that on there?
But Einstein...
I love it right now.
Einstein really wanted to know how the universe works, like all physicists. And, yeah, I mean, he really did come to a profound and deep understanding of really how gravity works. And so now you do have this question of, is gravity a real force? I mean, yeah, it is. I mean, you could make the argument general theory of relativity that that gravity only arises
Like it's a
because of the
side
deforming of space and time.
Like
and
it's a byproduct of space-time.
Of the curvature
of space-time.
of space and time. And
True, Mom.
but the real world ultimately works on quantum mechanics. And so
the nitty-gritty.
Yes.
The nitty-gritty of physics.
And so if you do really want to have a complete understanding of the universe, you do have to somehow marry quantum mechanics with general theory of relativity. These are two amazing pillars that really...
One's a real tiny pillar, though.
That actually deserves a drink. That really is good. That is good. One's a tiny pillar. It's a really tiny pillar. It's a Napoleon pillar.
He was 5'6". He was normal size.
He was normal, but you know.
Normal size.
But you know. All right. Anyway, so.
They didn't have LeBron Jameses back then in France.
Well, I'm sure they did. It's just they
yeah.
were probably in circuses and stuff. Meet the tallest man in
the
the world.
Man in the world. Anyway.
5'9". No, these were just like, these are pillars of physics, and they're used to describe the universe, and it's just at that intersection that we don't understand the universe, and they don't talk to each other. Quantum mechanics and general theory of relativity do not talk to each other at all. And so, but there's got to be some way in which, I mean, because the universe is not, I mean, yeah, all right, so quantum mechanics says, you know, you have, the universe is not smooth. Yeah, no, the universe is not smooth. But there's got to be some sort of continuity between general theory relativity and how it describes the universe and quantum mechanics and how it describes the universe. So, and so that singularity at the black hole means that our understanding of gravity is incomplete, and that ultimately we need something more. And
is it just we just haven't had that new Einstein to figure that out, or that technology to figure that out, to meld the two, or to find find that common ground.
Exactly. I mean, your Einsteins are. I'm not even going to say they're once in a generation. I mean, I really think you have Newton. And then you were lucky that you had Galileo and Newton that are really close to each other. But then you have to wait a few centuries, and then you get to an Einstein and a Niels Bohr, and these types. I really think that we probably won't have our next Einstein for another 100 years or so.
So it's like Yellowstone eruptions. It's just.
So, all right, we know that we live in the kill zone, but we watched this thing on, Bill Nye, it was the Bill Nye thing. And we watched this thing, and so we were looking up, are we still in the kill zone for Yellowstone? We are. We're going to die. Yeah. Yellowstone goes off. Yeah, but Bend, Oregon, not. That was also a place that we looked. How is Ben doing on this? Okay. Let's go to your mom's question.
How did we create anti-gravity to simulate it?
We have not created that.
All right, answer done.
That is, how did we? And so that is...
Okay, so we haven't created anti-gravity.
Yeah, no, we have not created. So, sci-fi has?
Science fiction.
Yeah, but...
what I love, and we've talked about this ad nauseum with how, like Einstein, in a sense, we think of things in a creative way of what could be or what we want in terms of like science fiction and like our media and books, TV, movies, etc. And then you have like the smart people that go, I'm gonna figure that shit out. I'm gonna see if we can make that real. And a lot of times we make it work. Like we have touch screens like in Star Trek. We got personal communicators. I can scan barcodes and shit.
I made a barcode.
You made a barcode that you can scan on the dome. Like,
Yeah, but you know the thing is like so. All right, so Star Trek does warp drive, creates a warp drive, and it really is a way of. Oh, okay. So I see where your mom. All right. Well, simulated.
Okay. The microgravity.
Well, no, it's the. Okay, hold on. Let me. All right. How did we create anti-gravity to simulate it?
Simulated for astronauts to acclimate.
Well, what they do is they do put astronauts in a big tank of water.
Yeah.
And basically make them feel like
they're floating.
Yeah, they're in microgravity.
Because the astronauts, they're in. It's not. There is gravity. They're in microgravity. And so it's
but that's because of the way
so really they're really in a perpetual free fall around the Earth. They're in a constant free fall. They're just going too fast to actually hit the surface. It's like Einstein's thought experiment, the painter or the window cleaner. They're just perpetually falling with no surface there for him to hit.
Yeah, and if you do want to put the surface there, you can actually have that window cleaner move. In like instead of straight down perpendicular to that, and they will move them fast enough. They'll be in free fall and they'll constantly go around.
The Earth curves under them, and so they just keep missing it, which is good for them.
Yeah, and Newton was the first one to actually kind of figure this out. He was like
weird. I mean, Newton's in the 1700s.
Yeah, and so Newton's thing was, what if I had a cannon? And I could shoot a cannonball. I shoot it, it goes and hits the ground. But what if I shot it fast enough and blow up the cannon? But if I shot it fast enough, it would go completely around the world. Can you do that? And the answer is yeah, if you don't worry about the atmosphere. So, but yeah, and so he was able to figure out Newton's cannonball. Was basically the first idea of a satellite around Earth. But your mom had a question about black holes.
Yes.
And what was that question again?
Hold on. She rephrased it in a text message. Light is absorbed by a black hole, or is there a calculation science can make regarding black holes and light, and does it have to do with the speed of light?
Okay, so the speed of light is constant, no matter what.
Yes.
So 186,000 miles per second.
186,000 miles per... Okay.
Or 3 times 10 to the 8 meters per second.
Ooh, look at you using the science...
I'm going to use the metric system.
What's it called when you do the 10 to the science? It's a thing.
Oh, scientific notation?
It's scientific notation. Thank you. Yeah. Thank you. Yeah.
So, I just feel like I look like Einstein just after a rave, after a long night.
With that shirt on?
I've been to the...
Einstein's had a long night.
I had a long night.
He's had a long night of thought experiments.
Anyway, so I think that... And this is nitpicking terminology, okay?
Okay.
So the light falls onto the black hole. It's not really absorbed by the black hole. Yeah. So it's two very different things in physics.
Yeah, it's more like it falls.
One is a very thermodynamic type of thing, which is the absorbing. So like you have this oven, and it has a heating element in it, and it creates this energy, and that energy is absorbed by the walls of the oven. But for light, what it does is it actually, due to gravity, falls onto the black hole. And basically you have this imaginary boundary called the Schwarzschild radius. And the Schwarzschild radius is where, at least from us on an outside perspective, time stops for something falling into the black hole. But once that Schwarzschild radius, you have to escape the black hole, you have to actually go the speed of light, which we know
it's not possible.
Since we have matter,
we can't do it.
We can't do it. But there is the photon. If it's aimed correctly, it can actually escape the black hole forever and never fall into it. But once you cross it,
once you cross the event horizon,
which you actually, there is no boundary that you know. Hey, I've officially crossed the...
There's no signage.
There's no
sign entering.
What is it like?
You shall not pass.
Well done. And I was gonna go with, isn't there like this thing that like Pirates of the Caribbean ride where it says something along those lines?
Oh, dead men tell no tales.
Oh, dead men tell no tales. But anyway.
Now Disney copyright strikes us just for that.
Whatever. Dude, I give you guys however much money a month. Give me a break. All right, so I fall into I pass that event horizon, that Schwarzschild radius, that event horizon, as it's commonly called.
Why? Side note, I'm sorry. Why is it called the event horizon?
That's a good question. I don't know.
Okay.
Because any events that occur inside of it, we can't see.
Oh, okay. So it's the horizon on events.
Yeah.
Okay.
And so, to escape the black hole inside that event horizon, you have to go faster than the speed of light, which light doesn't
light
do.
Light can't even do it.
And so it eventually falls into it. And so, what was it? Oh, we were watching Glow Up. Glow Up.
We like to watch a show on Netflix called Glow Up, where UK makeup artists have a competition to see who's the great makeup artist.
MUAs. Come on, use terminology. Anyway, there was one where I instantly pulled for her. She lost, but I instantly pulled for her.
But she won.
And she did a makeup that, in her eyes, was trying to show spaghettification.
Oh yeah, she did lose. Yeah, spaghettification.
Yeah, and I was like, holy
We're like,
shit.
Yes, spaghettification.
I am pulling for you.
I didn't think I'd hear the term spaghettification in a makeup artist competition.
I know, right? And so if you're not familiar with spaghettification, which is an actual scientific word now.
Oh, God. One of my favorites.
Which
my
is
second favorite.
Oh, that should have been a drink name, actually.
Well, no,
I know that I've...
Check out our Black Holes episode.
Yeah, I know I've described this, but might as well do it again. If you have an astronaut, myself, for example, falling into a black hole feet first, the tidal forces between my feet and my head are so extreme that I get stretched out.
Until eventually each one of your atoms gets
well, hold on, we get there.
Okay.
We get there. And so I stretch out, I get longer. But I also get skinnier, which is what I like. Yeah, so I'm getting skinnier. I'm getting the LeBron James. I can dunk a basketball. I'm tall. I'm feeling a stretch. It feels good. I can do yoga without doing yoga.
Tell that to the people in medieval times on the rack.
Well, speaking of them, you can only stretch so far before something happens.
Before something rips off.
Yeah,
your skin is only so stretchy.
And you tend to split in half, and eventually everything else goes pop.
Pop those protons. Then your protons do pop, Mom.
Yeah, and so it's not a good thing at all.
Dr. Proton Popper.
Yeah. Oh, that's a good one. That's a good show. That's a good show. We're gonna do it. Oh, because I mentioned it in the actual show, twin paradox. So in relativity, there's this thing, I'm sure you've heard of it, called the twin paradox.
No,
You've heard of it.
I mean, I've heard of it, but I don't know if all of our viewers do.
All right, so for the twin paradox is this paradox that arises, quote unquote paradox.
Now, are these identical twins or fraternal twins?
We're gonna say they're identical.
Okay.
These two are from England. Because apparently the entire country is twins.
It's a lot of twins.
A lot of twins in England. Anyway, watch Glow Up, and you know exactly what I'm talking about. So anyway, you have two twins. One stays on Earth.
Well, can be only a max of two twins. Otherwise, you have triplets or quadruplets or quintuplets or
yeah. All right.
septuplets.
Let's just say, oh God, Mark Kelly.
Mark Kelly and.
What's the other one? It was just him. Is it Scott?
Scott Kelly? Mark Kelly? Help us out, chat.
Oh, anyway.
The Kelly astronaut twins.
Yeah, one's a senator, and the other one was on ISS. Well, they were both on ISS at one point. But anyway, so...
Scott Kelly. Yeah.
Scott Kelly.
That seems right.
All right, so Mark and Scott Kelly. Because Mark Kelly stayed on the ground while Scott was in ISS. We're gonna let Mark go on his little. No, Mark's a senator. We're gonna let him stay in the Senate.
Yeah, we need him in the Senate.
We need him in the Senate. All right, so they're twins, and
they're kind of fraternal though, but
are they really?
They look different. They don't look identical.
Okay, let's say they're identical.
All right, we'll pretend they're identical. They're close enough.
Mark stays on Earth. Scott gets in a rocket and he flies off to Alpha Centauri. Proxima Centauri, the closest star to us, 4 light years away.
Yeah.
And he's going about 99.9% of the speed of light.
Oh, okay.
Yeah, he's going pretty fast.
Going pretty fast.
So from Mark's perspective, who's on Earth.
Going like, bye, bro.
Bye, bro.
I'll never see you again.
Time slows down for his brother, but from Scott's perspective, it is Mark that is actually doing the moving, and that Scott is staying still. And so if Mark does the calculations, Mark's like, holy shit, I'm gonna be 110 years older when Scott comes back. I'll be dead. All this kind of stuff. Scott does the calculations, and he's like, holy crap, I'm going to be 110 years older. But Mark's only going to be like 5 years older. Holy crap, I'm going to be dead. So who's right? Who actually ages?
They're both right.
Well, from a certain point of view. Star Wars reference.
Oh.
This is when Luke was talking with the Force ghost of Ben, and he's like, "Why didn't you tell me that that Darth Vader is my father?" And he was like, "Well, I told you the truth from a certain point of view."
Oh, right, that's right. And it's like, that's a bullshit answer. Whatever.
Yeah.
It's all relative.
It's all relative, right? So who's right? Well, the thing is like Mark is the one who actually ages 110 years.
Yeah, because he's not the one traveling at 99.9% the speed of light.
Yes, but special theory of relativity says if it's just the two of you, just the two of you in the whole universe, then yes, then it kind of washes out. But however, it's not just two of you. You have basically, because remember, there's no preferred frames of reference in the theory of relativity, and so it's not like Mark is more special than say Scott.
Right.
But Mark is kind of stationary relative to like the distant stars and things like that, and so it is really and truly is Scott that's doing the motion. But also Scott undergoes accelerations. Which Mark does not undergo, and that is the reason why, because he has to go there, he has to speed up, then he has to slow down, go around Proxima Centauri, speed up, and slow down and come back, and that is another reason why. Scott only ages 5 years, but Mark ages 110, but he's able to bring back Roe v. Wade. He becomes president and throws Trump in jail from a certain point of view.
This is going to be out of left field to make a baseball reference. But in one of my dreams last night, someone murdered Trump, or I murdered Trump, or somebody murdered Trump, or Trump was dead. I don't know. There was something that happened. That's all I remember is Trump being dead, and there was blood.
And there were celebrations around the world.
Oh, I'm sure. The Ewoks came out, and it was at the end of... It was a big Ewok party.
So is it? Yes.
Not a drink. I gotta borrow yours.
So it's the end of Return of the Jedi, and you have the fireworks on all the planets, and the Ewoks are doing their little party, and Luke and everybody doing their little party. And it's all because Palpatine's dead. Yes. Trump is fucking Palpatine.
Anyway.
Yeah, playing drums on the helmet. You got this little, steel drum kind of reggae beat going on.
Anyway.
Oh, that was good. I mean, that's worth the price of
That's
admission right
good.
there.
That's the second time you've used that phrase this week, I think.
Well, you started it like yesterday or whenever it was. It was, oh, we were talking about, you know, some personal thing with thing that applying.
Oh, right, okay.
So,
Okay,
yeah, I hope he's gonna be
anyway.
good.
Sorry, I didn't mean to take us off into that territory. But anyway.
Yeah, I mean,
All right.
you know, Einstein, this theory of relativity is a mind-blowing thing, but
Figuratively, yeah.
yeah, definitely not literally. But Einstein, it's because, you know, his thought experiments, he lived in his head for a bit.
Just some dude thinking about shit.
Yeah, and you know, it just kind of just thinking about it like deeply,
Mm-hmm.
and it revolutionized the way that we thought of the universe. But it's also Einstein when he submitted the special theory of relativity. Remember, he didn't win the Nobel Prize for that.
No.
He won it he could have.
Yeah.
But he was ridiculed in some places. He was.
They always are. Like, it always is. They're
Yeah.
ridiculed, and then it's like, oh, wait, it was right. Yay, applaud.
I know, right? He was ignored.
Mm-hmm.
There were also racist components to.
Because he was Jewish.
Yeah, it was called Jewish science. By
What does that
by
mean?
Nobel laureates, they called it Jewish science. And so, but he ignored all that.
Uh-huh. He persevered.
He persevered. He could have, at the end of the day, gone, I've put out these 3 just incredible papers. All 3 of them actually could have won a Nobel Prize. But, you know, the special theory of relativity just is not the end of the story.
Mm-hmm.
And I need to get to the end of the story. He was rejected for working at universities. That's why he was a patent clerk. He was rejected.
I mean,
But
look at that. That's you know, even Einstein's rejected. So, you know, if you get rejected from something, then keep going, because even Einstein was rejected.
yeah, and you know, I mean, I'm a couple drinks in at this point, but you know, it makes me think something Ron said. Like, you know, you got to tell your students that, you know, basically believe in yourself.
Yeah.
And
Yeah.
believe in your thoughts.
Mm-hmm.
And, you know, how many... All right, so... No, definitely. Okay, so when I was a kid, and you're in school, high school, you go to a guidance counselor and you say, hey, what am I going to do in my life? And they were like, hey, you go to college and study these things and that
I
thing.
don't think I ever talked to a guidance counselor.
Yeah, well,
That was probably a problem. But
I am 8,000 years older than you. I was born in 1875, so.
That's right. You're dead.
Yeah. So what would they tell girls? They would tell girls you need to be a nurse, or you need to be a teacher,
Or a mom.
or
A homemaker.
you're gonna be a homemaker. You know, it's and boys.
Even women weren't allowed to be teachers until like some
Oh.
ridiculous year.
Yeah. I don't.
Oh, and they had to be unmarried. As soon as you got married, you couldn't be a teacher anymore.
Yeah, because God
Because your
forbid.
role is in the house. Then you got to pop out those babies.
I don't really know what Ron's asking, but.
Oh, my mom asked, didn't he flunk kindergarten or something? Einstein. I think my mom's referring to Einstein.
Yes, Ron flunked kindergarten. It was you, Ron. You don't remember this, but remember, I was born in 1875, so I know all. Anyway,
Kindergarten is a German word.
it is a German word, yeah. And so is beer garden.
So is Ich liebe dich.
I don't know what I'm talking about
Anyway,
anymore.
okay, Einstein.
Oh yeah, and so yeah. How many Einstein girls did we miss out on?
A lot.
We did. How many African American Einsteins did we miss out?
A lot.
And you know, there's a lot of there is a lot of privilege that is part of education. I know that
look at school
like
funding.
some of my neighbors, some of our neighbors. I don't know whether it be mine and not yours, but some of our neighbors.
I didn't know if you're talking in the past, growing up in your neighbors, or
No.
Okay,
This
you
is
mean
like
currently?
now. This
Okay.
is now. Some of our neighbors that would be like, education is the same for everybody. No, it's not. No, it's not.
Are you kidding me? Inner city schools?
Inner city education is not the same as suburb education.
No.
I know that separate but equal was supposedly gotten rid of in the 50s, but we're still living this, and things need to change. Things need to change.
Yeah.
I don't know. There's a lot of changes. We're now
we can't
actually
teach critical race theory.
No, we definitely are taking steps backwards now.
Yes, Ron. I want to highlight Ron's comment that he sees his role in education not as a gatekeeper, but as a person who should throw open the gates and roll out the red carpet for each and every student who wants to advance. Yes.
Yes, exactly.
Yes. Oh, fuck DeSantis.
Yeah.
DeSantis.
All of these DeSantos type.
Let the kids be gay.
Yeah, all of these DeSantos things, and it's not just DeSantos; it's everywhere. It's really and truly at his heart. They never are going to admit this, but it's to continue white supremacy. It really is.
Well, yeah.
It really is. But it's also not just
Here we go. This is the political section of The Hangover with Cosmos the Cosmos.
This is what happens when you have a couple drinks. But it's not just that we need to make everybody feel included. It needs to be African Americans. It needs to be people that are from, Central America, South America that comes up.
As Ron's mentor, Dr. Palin, says, when we need as many different kinds of minds working on the world's problems as we can get.
Yeah, exactly.
A variety.
Exactly.
We need everybody brings something new and different to the table. A new perspective, a different perspective, a way to then,
it's a fucking rainbow. It really is.
It really is.
All right.
It's
the
spectrum.
rainbow has been taken by the LGBTQ plus community.
Because it's so colorful.
It is colorful, and the Christians are losing their minds certain Christians, the militant Christians, are losing their minds trying to get it back, to the point where, like, people at the Creation Museum are like, we're taking back the rainbow, whatever. But it really is a rainbow. You need to get that white light. You have to have every single color in it. The white light is impossible without all the colors.
And we don't say white light as in like a white light.
No. I hope they got that from context.
Yeah.
But I have had a couple of drinks, and so my context might be a little bit off. But anyway, yeah, you have to roll out that red carpet to everybody.
The only reason we've advanced as a species is from the participation of everyone. Where do you think algebra comes from? Algebra is Middle Eastern.
Yeah.
Okay?
Anything
that starts
Arabic
with
word.
A-L like that is from Middle Eastern.
It is an Arabic word.
The
Most of the stars' names.
The Mayans discovered the zero.
Yeah, they came up with the concept of zero.
It requires...
Star names. Star names are basically
a lot of them
Arabic
are Arabic.
It takes everybody. And, it's... all right. So Jack and Ron, you guys, at least that are in the chat and watching, you guys are teachers. Katie's actually in classrooms too, right?
Yeah, Katie has been in the educational field.
It's I commend you guys for rolling out the red carpet for everybody.
Inclusivity in education.
And it's. And
badass teachers. Yes, badass teachers.
Yes, #badass teachers. Because, LGBTQ students They have a lot to say. And everybody just wants to be accepted.
Mm-hmm.
Everybody wants to hear how they being their community, has advanced the story of humanity.
Yeah, is valid and is can
and
participate and is.
It's
Jack knows how to be badass. Yeah.
I mean, yeah. I in high school, there was a gay kid who was beaten up. I mean, badly beaten up for being gay, and that tends to shut people down. And DeSantis is shutting down. Basically, he is telling LGBTQ kids that they aren't valid and that they can't see. Representation is everything.
Mm-hmm.
It is everything. You do not feel part of a community. And so, Married at First Sight, you guys need to have same-sex couples. I'm just telling you. And so, you want to see yourself. You see yourself in the mirror.
Yeah.
You see yourself in the mirror, but
Yeah.
you want to see yourself in the community, in the story. And I got one in my mouth. It's still there. You want to see yourself portrayed in the stories on TV and books, and DeSantis is basically doing a book burning. And you know who else did book burnings? I mean, he's not doing a literal one, but the Nazis did a literal one.
Look, if you're doing anything Nazis did, you're doing something wrong.
Yeah, and it's getting rid of discussions about gay people or African Americans or the racism that occurred in this country does not get rid of gay people and African Americans and racism. Yeah. It does not do it. In fact,
it's still there.
It's still there, and in fact, you are shining an even brighter light on it.
Making abortions illegal doesn't eliminate abortions, people. It's gonna happen.
No, but you know what it does do?
Kill women.
It's gonna kill a lot of women.
And girls.
It is going to kill a lot of women.
Oh, wow, Jack. You're with us on Married at First Sight. I thought we were going to be the only ones, unless Katie was watching. Yeah, I figured there was, an issue with them not wanting to touch...
But they need... Okay.
That. But they need to.
They need to show that. They need to, because...
gay couples are going to have the same, similar issues and even more difficult issues.
We're watching the San Diego one. We're a little bit behind, but we're watching the San Diego one on the latest season 412. But, they need to do... They really... San Diego, California.
I know. Can you imagine the great TV drama of a gay couple on there?
Well, that would be...
Oh, my God.
Yeah, I know, right? But, maybe one season they'll do this. I do wonder, Pastor Cal, does he push back on it?
I don't think so.
I don't think so. I think they're very progressive.
Anyway.
We should have evolved past this and honor and learn from art. Yeah.
I mean, you would think. But, God, we're such a slow species to evolve.
You know it was crazy, though, is that all these, some of our neighbors go, America's a great melting pot. But they don't really want it to be a melting pot. They don't want to accept the melting pot. They don't want to accept They want this homogeneous state and everybody's the same. Mm-hmm. They want African Americans that bleach their skin and people from if you're from Central America and South America, they don't want you coming up anyway, but if you do then it's going to be you need to be American.
Yeah, I mean it's just that, and I've said this before, it's just that kind of evolutionary psychology of us versus them, mm-hmm. That we tend to still revert to, because the them is something we don't know or understand or can't really relate to, is scary, and then for some reason then we feel like it's a threat or what is going to take something away from us, when that's not in reality. In reality, you're going to grow and learn so much more by understanding the them, and you're going to be able to develop that empathy and
it's an opportunity
create
to grow
that
as a person.
Closer bond a connection with those who are different from you or think different from you, or but having I think we have a lot of growth that we need to do as a species.
Right.
Just societally, psychologically, technologically, just we really have a long way to go. And I think that, we have, we move, it is that whole thing where we like move 10 steps forward, or, we move like, a couple steps forward, and then it's like 10 steps back.
Right.
And then we move forward again, so it's like, but
Fits and starts.
at the end of the day, we are slowly moving forward because the majority gets larger in terms of that acceptance. And
so you think we'll get there?
I think. Well, I mean, if we don't die of all of our bullshit like climate change and shit first.
You're
but
such an optimist.
I'm really not.
Which is, the funny thing is, I really am. I think we're going to get there.
He's the optimist, and I'm just like, we are doomed. We might as well just throw it in the bucket now. And
I
we've been watching The End Is Nigh that just came out on Peacock, and I'm watching it, and there's like, hey, here's what we can do, people, and I'm like, we're never gonna do that.
Yeah.
We're never gonna we're just gonna die of all these things.
Yeah, and I really, at the end of the day, am an optimist, and it's interesting to see this dynamic, but I really think we're going to get there, but I hate saying this, the 80-year-olds need to die out. I mean, they do. It's just that really older generation.
I think that just maybe like all those Chads and Connors need to have like jet ski accidents, and
well,
the Rubios and the what's the other dude's name who's a dick? Cruises and whatever's need to have.
Yeah, Ted Cruz can go
some
fuck
sort of
off.
I don't know.
And somehow I hope this gets back to him. Ted Cruz can go fucking suck a dick. I mean, he can fuck off.
Oh yeah, Mom. To your point, Mom, yeah, it's power, greed, unregulated capitalism, white supremacy and religion. It's all just a means to maintain that control and that wealth and that.
And now you have religious,
bend the
Christian
society to your militism.
And
I mean that's the whole point of, and that's actually been the point of, say, institutionalized. And I say institutionalized a little bit lightly if I'm going back to, like, say, the Greeks, but institutionalized religion, it has been a means of kind of just creating those societal norms based on those who are in power. So it's like, for the Greeks, it was kind of like the Greek gods were actually they had human quirks. They were very, very human-like in a sense, and there were guidelines on what and what not to do based on what will make the gods angry or not, and that's the same thing. It's all a means of shaping the society and constructing those norms for whoever is in power. You know, I mean, personal, individual belief systems and stuff, that is a completely separate thing. When you have it as a construct, when there's a book that's written on how to behave, how to act, what's acceptable, what's not, that is really not about, at the end of the day, loving thy neighbor and shit. It really is, at the end of the day, like setting that basis of societal norms and what that society looks like, until you have the people in society going, wait a minute, this doesn't fit me. I don't accept this, and so you get those then changes over time, like Galileo giving the middle finger to the fucking Catholic Church and saying, "Earth's not at the center, assholes."
Or that.
A little, or if you're a Friends fan, So it really is, at the end of the day, about that, maintaining that power and control over society, from the viewpoint of those who are currently in charge, who currently have that power, and a little by little we erode it, by little.
But you know how you erode it is that all of us have to do two things. We have to vote, However, we also need to make our voices heard and our voices known. And there is admittedly a very passive way in which we do it. Liz and I do it.
Hanging flags.
Yeah, because but you know what? It's
Get
only
offended by
because
this uterus hanging from our house.
I know, right? It's only because we're not going to talk to each person that walks past our house. And so we have to resort to this passive way of doing it.
Have I told you about my God and Savior abortions?
Satan! But anyway, we have 3 flags that we hang outside of our house. We have the Bi-Pride flag. We have the rainbow flag.
American flag. A rainbow American flag.
Rainbow American flag.
God, I wonder how much that pisses people off.
Yeah, I love it. And we also have the Don't Tread on My Uterus
Don't tread on
flag.
my uterus flag, which is like
and Don't Tread on Our Universe.
Oh, yeah, which is like the libertarian Don't Tread on Me flag, but just with a uterus in the middle of it.
Yeah. And we've had people actually look at it and shake their heads in disgust.
But then we've had people that say they like our flags.
Yeah,
and thank us for having them up.
We had
and
this
then we've
one
had
lady,
people rip them down.
We had this one lady literally get out of her car and take a picture of it.
She was taking pictures of our house. Oh yeah, no step on snake. I just want to comment on a couple things here. So Jack said a fast way to freak out students on the Get to Know You survey I give the students has a line saying, name your preferred called pronouns. Do your parents know this name? And so many kids saw this.
Well, that's a good question.
And then they bought into the idea that his class is a community. And that at the end of the day, we're a community. Like, we're a community that should all be working together, supporting each other, believing in each other. And it's not like, these people that are like, I don't have kids, I don't want to pay taxes for education. It's like, these are the future of your community. Like, you know, like you live in this community, so it's your responsibility as a member of this community to
have a well-educated community,
to pay your part into it, to help develop it, to keep it going, to maintain it, to help maintain the roads, to help everybody succeed and prosper, live, what is the Declaration of Independence?
Life, liberty, and
pursuit of happiness. Like, our role in this community we call a country, and also, I dare say, the world we live in, because the countries are just made up bullshit lines that we drew on a fucking picture. That at the end of the day, we're all here. We should all be supporting each other, because it's that cliche line. You're only as strong as the weakest link, the weakest person.
The thing is it disappeared. It's just some sort of error.
Oh, okay.
You can't have.
Oh yeah, we might be buffering.
You can't have American individualism and a sense of community at the same time. So all of our right-wing buddies need to make a choice. But also, for Jack, I think that is an amazing follow-up question. Do your parents know?
Yeah.
Because it's one thing to say, what is your preferred name? But when you say, do your parents know, you're signaling to the kid, or really to whoever, this is a safe space.
Yeah.
And you tell me the name, I will call you that name. But if your parents don't know, it doesn't go beyond this.
Yeah.
And so that actually is a really great follow-up question that I hadn't thought of, and I think that's great.
In fact, there's signs around our elementary school that have me questioning, that have me a little bit. There's signs that say, like, we see you, we've got you, and I'm like, but do you?
Well, it depends on who puts it up.
I mean, it's here, so I'm like, that's a nice placating message, but do you though? Like, what are they really trying to say there? Anyway.
Yeah, okay, so we've talked about having our flags.
Mm-hmm.
I really do hope that kids see those flags and they understand that they have an ally, that they have somebody that sees them.
Yeah.
Even though we don't know who they are, we see them, and that they are accepted. And we are a long way from relativity.
We're so.
But you know what? Relativity at its heart is a way in which you are to agree with somebody else on something. So it is a way in which to see the other person's point of view.
So
and we really need more of that in the world.
Relativity is just empathy.
Empathy, yeah. And so, I mean, we need more of that. We need more of that in the world. And we need for people to stand up and say, and the good news is a lot of those people are watching this, is that they need to stand up and fight back against the darkness, fight back against what DeSantis and Trump and Cruz, all of these people represent. They represent darkness. They represent holding back society. They like to say, "Oh, I'm very religious and Jesus blah 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 blah. Love your neighbor," but they're really not.
Jesus was Middle Eastern.
They're really only interested in themselves.
Yeah.
They're not interested.
Yeah, no, it's about that maintaining control and power.
But we need more. We need more people to speak up. Unfortunately, progressives don't like to speak up. They're not.
It's like we like to have marches.
Yeah, but but
then we don't always like to come out and vote, which is actually kind of what matters.
But
you don't want a DeSantis, you got to come out and vote for somebody else.
The problem with marches is you're able to disappear into the sea of humanity, which is fine. But our quote unquote friends on the right have no problem. Just being an asshole.
Yeah.
Individually.
Yeah.
And to be honest, we need more assholes on the left. So I have no problem.
We need more people on the left need to play a little bit dirtier. A little dirtier. Not like corrupt dirtier. Just a little. Just be a dick a little bit.
And you know what? I'm going to do this more often. I wore my pro-life shirt. No, my pro-choice.
What?
I wore my pro-choice shirt out yesterday as we went out. We had to run some errands. And so I wore it out. And it was interesting. I'm
surprised that guy at PetSmart was like... complimented your shirt.
Yeah, I had at least 10 people look at my shirt and read it, and there was only one person who really said anything. It was a guy at PetSmart, and he said, "That's a great shirt." And basically the shirt said, I think I wore it on one of the shows, but it basically says, if you don't like abortion, just ignore it, just like you do with foster care. Children in foster care. But I'm also going to probably start wearing my Fuck Nazi shirts out. Because I am so pissed off at people right now that I really and truly want to be in their face, and I want to be a reflection of the asshole that they are, but right back at them and basically saying, "You're a goddamn asshole." And this really comes from the punk in me, where I'm just like, "Fuck you" to all these people. I am so angry at them.
You should do it with this wig on.
Yeah, but then they look at my wig and they don't look at the shirt. But anyway, you know what? It's about time to make some pizzas.
Yeah, I think we've gone on long enough with this traditional hangover, which delves into just social commentary.
And let me just say,
with like-minded minds.
We took the dogs for a walk this morning, and I was like, I don't have any politics to talk about.
We can always get into it.
I literally said that, didn't I? I said that. I think I set it up at like the Stonehenge of Ogden. But anyway, thanks for joining us. We are going to be off next time.
Oh, yeah. Let me pull my calendar.
Yeah. And so we're going to take a little tiny break as we make our way to Central Oregon.
Where are we right now? What day is it? 28th?
Sure.
Okay, so normally we would have an episode on the 11th.
So is it 29th?
So we will be back September 25th.
Oh, that's right.
Season 4 of Cosmos with Cosmos.
Yeah, so we're so if you have any things that you want us to talk about. I know that your mom has already sent us something about Big Bang.
It won't be an actual vacation though, Ron. We'll be working. We'll just be doing it from Oregon.
Yeah, but we are gonna take a break to be with family, so it is gonna be a vacation.
So we won't
from
be
the show.
it's a vacation from the shows per se.
And so thanks for joining us, and thanks for being with us for this season as we start season 4 next time. Everybody stay safe, stay healthy, raise your voice, make the world a more inclusive place, and we'll see you in a couple weeks, in 4 weeks. Cheers, everybody, and
Bye.
peace.
Bye. We'll see you later. Adios.
Adios.